Hola, 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 ¿cómo están mis estimados? Buenos días, buenos días. Pucha, solo tenemos dos estudiantes.
Buenos
Bienvenida.
días, mister.
Buenos días, Lorna. Buenos días, María José. Rocío están uniéndose ahora. Hoy sí ya mejor. Ya decía, pucha, solo dos estudiantes se me quedaron durmiendo para Semana Santa. All right, welcome everyone. It's good to see you again. I hope you're enjoying your vacations. And today we're going to start over once again with the second unit of the lessons. Actually, the 2 weeks ago, we learned how to solve existing equations in using three variables, right? And now we're going to start again with the second unit of the linear algebra. In this case, we're going to learn how to solve these equations, obviously, but using matrices. But before to do that, we want to learn what does that mean a matrix, how to apply the algebra of the matrices. When I'm saying algebra of matrices, we're going to learn how to add, subtract, multiply, and calculate the inverse of the matrix. And after that, we're going to learn how to solve the system equations in three variables by means of matrices. And also we're going to learn what will be the concept of determinants, Kramer's rule to solving system of equations. But we're going to learn what is the basic concept of the algebra of matrices. Well, actually, what is a matrix? My dear students, the matrix we can define in simple words with the arrangement of the numbers in rows and columns. For example, those matrices can be given by the following numbers. In the first one, we can label the matrix, label the capital letter A. Yes, Julio, tell me. Sí, Julio.
Mister, solo una pregunta antes de que empiece sobre lo del Día de la Madre, que no estuve ese día. ¿Cuántas fotos había que subir?
Mm,
Oh,
yo creo que yo les pedí como dos, no me acuerdo. Dos o tres, uno o dos o tres, las que ustedes puedan. No hay problema.
bueno, dele,
Dele,
ok.
dele. All right. So this is going to be example. This capital letter A that means matrix A. And that symbol like a bracket, we can consider the matrix. And we can write our numbers. For example, we got 5, 83, 2, 1/2. This is a one matrix A. The arrangement in the rows and columns for these numbers. And we got a matrix B given by, for example, 2, 0, -5/2, 6, 3, -3. All right. Both are matrices. All right. Because this is our arrangement in brackets. As soon as you can see, of the numbers could be whole numbers, could be decimal numbers, could be negative numbers, could be fractions, but never rational radical numbers never happens. I mean, square roots or cubic roots never happen in the algebra matrices. But in this situation, we have two kinds of matrices. We got the square matrix and the rectangular matrix. What is the difference between them? The square matrix, my dear students, we call square matrix because this matrix had the same dimensions. I mean, the same number of rows with corresponding the same number of columns. All right. For example, the matrix A, how many rows do we have? How many rows do we have in the matrix A?
Four.
Rows. ¿Cuántas filas? In the matrix
Two.
A? Two, right? And how many columns do we have?
Two.
Two, right? So in the first one, because we have the same number of rows and same number of columns, we can call this one a matrix 2 times 2. But that doesn't mean I'm going to multiply this matrix. That means we have 2 rows times 2 columns. In this situation, we can call this one like a square matrix because it has the same dimension, the number of rows corresponding the same number of columns. This is by one hand. By the other hand, in the second matrix, how many rows do we have?
2,
2. How many columns do we have?
3.
3, right? So in the second one, this is a matrix that we call 2 times 3. That doesn't mean I'm going to multiply that will be equal 6. No, that means this is going to be a matrix who has 2 rows, 3 columns, and the name of the second matrix that will be rectangular matrix. This is the two kinds of matrix, the square matrix and rectangular matrix. But I'm not saying precisely always will there be 2 times 2, 2 times 3. Just I want to clarify what will be the difference between them. Either have the same dimensions, 2 times 2, 3 times 3, 4 times 4, 5 times 5, and so on. That means we have the square matrix because the quantity of rows, that will be the same number of the quantity of columns. In the rectangular matrices, obviously the rows and the columns will be different. And obviously in the matrix, there is no community property. What does that mean? That means if I said 2 times 3, that will be totally different than 3 times 2. Because when I say the matrix 3 times 2, let me label an example, the letter C. Obviously, this is going to be another rectangular matrix. When I say it 3 times 2, that means, let's take a look. 3 times 2, that means I'm going to have 3 rows. 1, 2, 5, negative 5, 4, 5, 6, and 0. Okay, if you see this matrix C, this is not corresponding to 2 times 3. This is corresponding 3 times 2 because we have 3 rows times 2 columns. But also this is going to be a rectangular matrix. For that reason, I'm telling you that matrices are not community. No son conmutativas. So the order, the factors in this case will affect the final result because as soon as you can see, it's totally different when I said the matrix 2 times 3 because we have 2 rows, 3 columns, and I'm saying 3 times 2. That means I have 3 rows and 2 columns. And the square matrix are the arrangement of the numbers into the brackets who has the same dimensions into the rows and quantity of columns. Okay, what are we going to learn? Well, for the first unit in the matrix, we're going to learn how to add, subtract, and multiply, at least for a while. But let me tell you one secret with the addition and subtraction of matrices. There's one singular secret. In the moment we're going to add or subtract matrices, there's one singular secret. To adding or subtracting matrices, that's supposed to be the same size, the same size. It could be a square matrix, it could be rectangular matrix, but we can add a subtract matrix when we have the same dimension. I mean, a matrix 2 times 2 can be added or subtracted with another 2 times 2. 2 times 3 can be added or subtracted with another 2 times 3. 3 times 2 or subtracted with another of the same size. What happened is we supposed to add or subtract matrices with different size. Simple. There is no solution. Don't forget that simple golden ruler because the most of the students forgot this one. And actually, I remember a few years ago when I was a math teacher in Agape, I'm telling the group of the students 3 exercise or matrices. They're supposed to add us to the matrices. All of them are different size. And the students, I don't know what they have to do. They're doing a lot of things but never doing the right answer because they're adding zeros, they're multiplying, they're also dividing and including or completing the zeros. So I don't know what they have to doing, but the only simple answer when you have to add or subtract matrices with different size is simple, no solution. There is no possibility for adding or subtracting matrices. Okay, so let me give you one single example. For each case, we have a matrix given by 2, 3, 5, and 2. Okay, and we got matrix B given by the equation 2, 0, 3, 1, 0, 1. And we got the matrix C, -5, -2, 0, and 1. We got three matrices, A, B, and C, okay? And the requirements are find letter A minus 2B. Letter B, 2B plus 3C. And letter C is C plus A. This is the requirement. Okay, the commands. We have the three matrices, A, B, and C, and they're asking for A minus 2B, 2B plus 3C, and C plus A. And let's see what we got. All right, for example, in the first command, A minus 2B is the first command. Who's going to copy the first matrix? The matrix A, you know, is 2, 3, 5, and 2. Okay? Minus 2 times the matrix B. What is the matrix B? 2, 0, 3, 1, 0, 1. You can multiply because the multiplication, the product between one number to the matrix, the name of this one is the scalar times a matrix. The only thing that we have to do is multiply the number 2 by the rest of the matrix. I mean, I'm going to copy 2, 3, 5, 2, negative sign, open the brackets, and only the number 2 multiplying by the rest of the matrix. I mean, we got 4, 0, 6, 2, 0, and 2. But at the moment we go through, what's happened in this case? We have a matrix 2 times 2 versus a matrix 2 times 3. If this matrix is the same size, it has
No.
no. For that reason, the answer for the letter A is no possible or no solution because these both matrices have different size. You can start with the statement, we can multiply the scalar of the number by the matrices at the moment we through. To adding also starting the matrices either have different size, no possible. Look at the letter A. How about in the letter B? We got 2B plus 3C. Like a second example. Okay. Let me put the number 2. Remember the matrix B, we got 2, 0, 3, 2, 0, 3, 101 plus 3 times the matrix C. What is the matrix C? -5, -2, 0, and 1. Okay, let's going to do it again. The number multiplying by the matrix is simple. We're going to multiply all the matrix by 2. We got the matrix given by 4, 0, 6, 2, 0, 2. Subtracting, adding the number 3 by the rest of the matrix. I mean, negative 15, negative 6, 0, and 3. Which fail. So, same questions. Is those matrices are the same size? No,
No.
right? So, again, second answer. No possible. No possible. The second option. The third one, C plus A. C plus A. Okay, C plus A. I'm going to use the blue one. Let's see. Matrix C is negative 5, negative 2, 0, and 1. Okay? Plus the matrix 8. Matrix 8 is 2, 3, 5, and 2. I have a question. All matrices have the same size? Yes or no? ¿Tienen el mismo tamaño? ¿Sí o no?
No.
Sí, sí lo tienen. ¿Por qué no? No son 2 por 2 este y este no es 2 por 2. ¿Sí o
Tiene el
no?
mismo tamaño. Sí.
Tienen el mismo tamaño. So in this case, we can perform the operation because we have 2 rows, 2 columns, 2 rows, 2 columns. How are we going to perform this operation? It's simple. We're going to add or subtract position by position. I mean, we got negative 5, right? Negative 5 plus 2 will be negative 3. Yes or no? Negative 3.
Yes.
Second one, negative 2 plus 3. Negative 2 plus 3 will be 1, right? Negative 2 plus 3,
Yes.
1. How about the number 0? 0 plus 5, 5. And 1 plus 2, 1 plus 2 will be 3. And this is going to be the solution for the part C. Understood?
So if they have the same measurements, we need to
They have the
the
same size and add us starting. And what's happened, the position with the position. That's it. The first with this one with this one, this one with this one, this one with this one. And that's it. Let me apply another concept. For example, let me give you another example. I'm going to copy over there. Don't worry about it. Let me see another example. Okay, another example. We got matrix 8 equals 293, 0, 5, 293, 0, 5, 0, 5, 7, 1/2. Seven 1/2. This is the matrix A. Matrix B. Matrix B 1, 0, negative 3, 1, 1, 0, negative 3, 1, 2, 2. A, B. I got the matrix C. That will be 7, negative 3, 0. 7, 83, 0, uh, 0, 1, 5, 0, 1, 5. In D, we have 6, 0, minus 6. 6, 0, minus 6. 8, 1, 9. Okay, we got 4 matrices. And this time we have to find, chon, 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 chon. We have to find A plus B, C minus D, A plus B, C minus D, C minus D, C plus A, C plus A, and also 5, 8 minus 2B. Okay, we got the second example of the matrix. If you have doubts or questions, don't hesitate to let me know. We got the 2 requirements, A, B, C, and D. All right, let's going to start with the first one. A plus B. A plus B. Okay, matrix A. Tienen que fijarse siempre si tienen el mismo tamaño. 2, minus 3, 0, 5, 7, 1.5. Okay, plus matrix B. Matrix B is 1, 0, -3, 1, 2, and 2. So I have a question for you. Those matrices have the same size? Yes or no?
Yes.
Yes, of course it is, right? So let's going to add or subtract the position by position. I mean, 2 plus 1, 3. -3 plus 0, -3. 0 plus -3, -3. 5 plus 1, 6. 7 plus 2, 9. 1/2 plus 2, 1/2 plus 2. 2 is 4/2. That will be 5/2. And that's it. We got the first answer, A plus B. Simple, right? Now,
Yes.
now C minus D. C minus D. C minus D. We got 7 minus 3, 0, 0, 1, 5. Minus D. D is 6, 0 minus 6. And 8, 1, 9. Both have the same size? Yes or no?
Yes.
Yes, right. So let's going to apply the position by position. I mean, 7 minus 6, 1. -3 minus 0, -3. 0 minus 6, positive 6, because negative times negative is positive. Again, 0 minus 8, -8. 1 minus 1, 0. 5 minus 9, negative 4. All right, we're all doing so well. We have A plus B, C minus D. Another one, C plus A. C plus 8. Let's see what we got. C plus 8. Okay, matrix C. 7 minus 3, 0, 0, 1, 5, plus 8. 8 is 2 minus 3, 0, 5, 7, 1/2. Their those matrices have the same size?
And no.
No. For that reason, no solution. Because the matrices are different, have this different signs. It's simple. You don't need to apply another regular theory and something like that. No, there's no possibility to add us start the matrices because the adding us start the matrix both had that they're supposed to have the same size. Okay. And finally, I don't know if may I erase this part of the whiteboard or not yet.
Yeah.
Not yet.
Yes.
Okay. Okay. Creo que aquí me cabe. Creo que aquí cabe. Antes de borrar. Creo que no hay necesidad. We got 5, 8 minus 2b. Cabe, cabe, cabe. No hay necesidad de borrar. We got 5 matrix 8 is 2, negative 3, 2, negative 3, 0, 5, 7, 1/2. Minus 2 matrices. B is 1, 0, 1, 0, negative 3, 1, 2, and 2. Okay, first of all, every time that we have a number multiplying a matrix, well, that number has supposed to multiply the entire matrix. That means we got 10, 0, 35, negative 15, 25, and 5/2. This is by one hand, okay? By the other hand, negative, and the same happened with the number 2. We got 2, negative 6, 4, 0, 2, and 4. Okay? Now, all matrices have the same size? Yes or no?
Yes.
Yes, it is, right? So we're going to do it position by position. 10 minus 2, 8. Negative 15 minus 0, negative 15. 0 minus minus 6 will be positive 6. 25 minus 2 obviously will be 23. 35 minus 4 will be 31. And 5/2 minus 4, okay, minus 4 es 8 medios, negativo, 5 menos 8, sería 3 medios. That will be negative 3/2. And this is how, my dear students, we can add, subtract, and multiply one number for one scalar matrix. Questions?
Uh, 5/2 plus 4 will not be.
Mhm.
Forget it. Sorry.
It's simple. Remember, The number multiplied by the matrix. That name of this one is scalar, product of the scalar. And after that, when you're multiplying the number, the matrix, you must to add or subtract depending the case. Either have the same size, go right ahead. But if they have a different size, just like at this example, it's not possible because in this example located over here, we have different size. For that reason, we cannot perform the same answer. Okay, we cannot perform the same an answer because they have different size. May I erase the left side of the whiteboard or not yet? Let me know when you're finished.
Already finished it, but I don't know the others.
The other ones, may I erase the left side of the whiteboard?
Yes.
All right then. Do. Okay, we learn how to add, subtract matrices, and we learn how to multiply a number by a matrix. But what happened at the moment we're going to multiply a matrix by another matrix? What, as a matter of speaking? Okay, guys, every time that I want to multiply a matrix by another one, obviously to multiply, one of the requisites will be, we can multiply square matrices by square matrix. Of course we can, because they have the same size. We can multiply a rectangular matrix by a square matrix. We can do that. But how we can do that? Simple. We're going to do that only if and only if the quantity of numbers located in the row are supposed to be the same numbers of the column. For example, let me give you an example. We got a matrix A given by the numbers 2, 3, 1, 0, 0, 2, 1. This is going to be the matrix A. Okay. Now let's going to do it with the matrix B. The matrix B, we got 4, 1, 0, 2. All right. And the problem asking for find letter A. B8 and letter A, AB. Remember, what did I tell you? There is no community property in the matrices. I mean, aquí aplicamos el dicho en español, no es lo mismo decir arroz con pollo que pollo con arroz. It's totally different, this concept. For example, in the first one, the matrix B, that's supposed to be 4, 1, 0, 2, right? Multiply by the matrix A is 2, 3, 1, 0, 2, 1. Let me show you how we can perform this product. This is the command B8. Obviously, we have to multiply a square matrix by a rectangular matrix. How we can make sure if it's possible to perform this operation? Simple. The only thing that we must do is to check if the quantity of numbers of the row, the first term, the matrix of the left, correspond the quantity of numbers to in the first column of the second matrix. If there's correspond, they are matching, we can perform the product. But if they are not matching the first row with the first column, there is no possibility to do it. In this case, how many numbers do we have in this row? We have 2 numbers, right? And this column, 2 numbers. So that means we can perform the product with the matrices. How we can do that? This situation. It's simple. Please take a look. The operation of this one will be multiplying. Oh, yeah, yeah. The first two numbers with the first two numbers of the first row, first column, and repeat the operation. Row with the second column and row with the second column. And after that, the second number 0 and 2 by the three columns. I'll do it step by step. And I'm going to show you what will be the process. Please focus, pay attention. I'm going to multiply 4 times 2, 4 times 2, and the result, and the second one always, I'm going to add the second product. I mean, 1 times 0. And that's it. Again, 4 times 2 plus 1 times 0. And we got the first answer. Repeat the process with the second column. I mean, 4 times 3 plus 1 times 2. Simple. Again, this 2 by the last two ones. I mean, 4 times 1 plus 1 times 1. And this is going to be the operation with the first row with the three columns. Again, 4 times 2 plus 1 times 0. 4 times 3, oh, sorry, 4 times 3 is this one. No, yeah, we are right. 4 times 3 and 1 times 2 plus 1 times 2. And the last one, 1 times 4 times 1 plus 1 times 1. And what happened with the second one? Over here, we're going to repeat the process. 0 times 2 plus 2 times 0. Another one, 0 times 3 plus 2 times 2. And the last one, 0 times 1 plus 2 times 1. And that's it. Now, because we are operating this equations or this matrix, that's going to simplify. What will be the answer? 4 times 2, 8 plus 0, obviously, will be 8. This is going to be 0. 4 times 3, 12. Plus 2, 14. 0 plus 4 will be 4. And the last one, 4 plus 1 will be 5. And 0 plus 2 will be 2. And this is going to be the answer from the product between B times A. Understood?
So if there are like, for example, three rows, we cannot multiply so if in letter B no, if in letter A there was 3 rows, we could multiply the B with the A, right?
Exactly. In the second one, we cannot perform the operation. If you see in the second example, in the letter B, A times B, A times B. Remember the matrix A is given by 2, 3, 1, 2, 3, 1, 0, 2, 1. They're supposed to be multiplied by what? 4, 1, 0, 2. And at the moment I'm going to start with the product between them, we must check if the quantity of numbers in the first row that's supposed to match with the quantity of numbers with the first column. We have 3 numbers over here, right? But here we got only 2. What's happened in this case? Simple, because they are not matching the quantity of numbers on the row, in the first row with the quantity of numbers in the first column. That means no solution. Okay, because of the moment we're going to apply the product, the quantity numbers in the row that's supposed to matching with the quantity numbers of the code. Okay. Tomorrow we're going to continue solving problems or examples of the product of matrices, because in the algebra of the matrix, we can say the most difficult part is learning how to multiply the matrices. But if you ask me, the process will be the same. Always make sure the quantity and numbers of the first row matching with the quantity and numbers of the first column. If they're matching, we can perform to do that. But if there's no matching, there is no solution. Okay. Okay, guys, thank you so much for the attendance. We are out of time. It got wills tomorrow. I'm going to continue solving products of matrices. Take
Bye,
care of yourself.
Mister.
Have a
Bye,
great, wonderful
Mister.
day. Bye-bye.